Hey everyone, in this video we'll take a look at V2I converters using op-amps. This includes the ground load V2I converter and the floating load V2I converter. Both of these are supposed to be independent of the load resistance. We'll test this hypothesis in the video. So first we have here a ground load V2I converter. It is called the ground load because the load resistance is directly connected to the ground here. This configuration is independent of the RL resistor since the equation for the current through the resistor RL is given by IL is equal to Vin by R, where R is the value of any of these resistors up here. Hence, it is independent of RL. Now, if we perform the bias point analysis on this schematic, we'll get the value of output current. So, here we get the value of output current for 1 volts, which is 3.99 milliamps, which is almost equal to 4 milliamps. If we increase the value of voltage to, suppose, 5 volts, and run the simulation again, the value of the current changes. It becomes 19 milliamps. This holds with the equation since the value of the output current should change with the input voltage. We'll change the voltage back to 1 volts and run it again. So now, keeping in mind this value of the output current for input of 1 volts, we'll change the value of RL. So from 250 ohms, we'll get the value of RL to 2 kilo ohms and run the simulation again. We can see a change in the value of IL. It has become 2.5 milliamps. We'll test it further by changing RL to 50 kilo ohms, and again we see a large change in the value of IL. It has become 110 microamps. Finally, we'll change the value of RL to 100 kilo ohms. So here we can see that the current has become 55 microamps. We can clearly conclude that our hypothesis was wrong, at least for the grounded load configuration, that the output current is totally independent of RL, since we can see a clear relationship here. We'll get into this logic later. First, let's take a look at the floating load configuration. Here we have a floating load configuration. It is named as it is because of the load which is floating. While running here we have the floating load configuration. It gets its name because of the load which seems to be floating. Now we'll run the bias point analysis on this schematic for an input of 1 volts. We get an output of 1.367 milliamps for RL of 10 kilo ohms. If we pull the value of RL down to 2 kilo ohms and run the simulation again, we get 3.99 milliamps. So the current changes. Bumping the value of RL up to 50k and simulating the results, we have 279.81 microamps at the output. Finally, for 100k, we have output of 140 microamps. Here too, the relationship of Vin and IL, which was supposed to be IL is equal to Vin by R, where R is this input resistance, has been proven false. So, what we can conclude is that although these circuits are theoretically verified, these do not work in practice. Here we need to use actual V2I converters which are made industrially, and homebrew circuits do not work. Now, one such mass-manufactured IC for V2I conversion is the XTR111. Here in its functional diagram, we can see that it does not use any resistors internally. Instead, it has MOSFETs and an external R set resistor to control the magnitude of I out. So, this means that having any resistors at all would change the output resistance value according to the resistance. This would imply that having any resistor at all would create a dependence of the output current on the resistor value. Mass-manufactured circuit for V2I conversion load independent is the XTR111 circuit. Here we can see that instead of resistors, it uses MOSFETs internally for a lot of its operations, and it only consists of resistors externally connected to set the I out magnitude. So this would imply that having any resistors at all in the circuit would create a dependence between the output current and the resistance load. So this has been a look at V2I converters using op-amps, which are supposed to be load independent, which is found to be only theoretically true. So thanks for watching.